18BEC01. My name is Vellanki Venkata Tharun and my register number is 18BEC0112 and my slot is C1. Now I am presenting my DA-1 topic of computer organization and architecture, and I have chosen a microcontroller, and the microcontroller I have chosen is DLP-PC7541 Texas Instrument microcontroller, and I am doing this course under Professor Dan Balar, and my professor has given me some set of questions. Now I am going to explain those questions for you. And the first question is that draw a clear diagram of microcontroller, and the tool I have used to draw this diagram is Drawlo. And this my microcontroller block diagram consists of motor controllers, motor drivers, some logic units, serial interferences, and 5G regulators, current resistance and charge pumps, etc. And this is the internal block diagram of each block diagram, and these two blocks are connected by power management, temperature, and these are the another block diagrams of each block. And the second question is provide an instruction set of microcontroller with clock cycle, required machine cycle, memory required, flag affected, and type of instruction based on addressing modes and operations. And these are some of the instruction sets of my microcontroller, and these are the minimum and maximum units, and these are some text conditions, and these are some text conditions, and this is some control logics and their text conditions and everything, and this is switch regulators and their maximum and minimum units and their units and everything, and at average voltage of 0 ampere to, and these are all the test conditions of those things, and these are the signals of my microcontroller, and these are the characteristics of my microcontroller and their test conditions and their units and their maximum and minimum units. And the third question is explain the microprocessing element. And basically a DLP-PC7541 controller supports an 4K Ultra HD high definition resolution, and it supports at 60 Hz 4K UHD. At 24 Hz it supports 1080 pixel, and at 120 Hz it supports 3D 180 pixel, and also it contains USB 2.0 high-speed OTG controllers, and mapping engine 1D, 2D, 3D keystone corrections and parameter surface corrections, and improved linear and anamorphic scaling and addition scaling processes, and dynamic block, Boolean block and frame conversions, and color coordination adjustments, and on-screen display, integrated 2G bit frame memory elements, and for external memory units, and for external memory support, and parallel flash, MUPW sequences, and system controllers, and this is the block, and this is the diagram of power up sequencing time diagram when the power up in the of my microcontroller. And this is the power sequencing time diagram of my microcontrollers, and this is the condition when the system is shut down. And the fourth question is correlate the microprocessing element and architecture with the architectures discussed in module 1 and module 2. The architectures discussed in module 1 are non-Neumann architectures and hardware architectures. One Neumann architecture is based on the stored program computer concept, where the instruction data and program data are stored in the same memory, and this is the block diagram of that microcontroller. And the next one is an hardware architecture, and the hardware architecture stores the machine instructions and the data in the separated memory units, and they are connected by different businesses. In this case, there are at least two memory addresses spaces to work with, and there is a memory register for machine instructions and other memory registers for data, and computers designed with hardware architectures are able to run a program and access data immediately, and therefore simultaneously. Hardware architecture has a strict separation between a data and the code, and thus hardware architecture is more complicated, but separate pipelines remove in a bottleneck of non-Neumann creates. And this is the block diagram of hardware architecture. And the fifth question is elaborate the registers and organization of microprocessing element. and these are the registers that I have used in my microcontroller. And the first one is an interrupt set enable registers, and interrupt clear enable registers, and interrupt set pending registers, and the interrupt clear pending registers, and interrupt bit I2 registers, and interrupt priority registers, and software trigger interrupt registers, and auxiliary control registers, and CPU ID base register, and input control state registers. And these are the registers I have used. And the next thing is explain the type of algorithm used for unsigned calculations and signed calculations. And traditional digital signal processing were designed to execute and signal processing algorithms efficiently. This led to the some serious compromises between the developing a good DSP architecture and a good microprocessing architecture. For this, as weather reason, most of the DSP applications used a DSP and a microcontroller, and add, subtract, multiply, or divide the values of those registers, placing the result in a registers, possibly getting one or more condition codes in a status registers, and increment discriminate in same ISA, saving operating operand fetch in trivial cases, and performance bitwise operations, taking conjugations and disconjugations of corresponding bits in a pair of registers, and taking a negation of each bit in a register, and comparing two values in registers, and floating points in instructions of for arithmetic on floating point members. And this is the block diagram of that. And the seventh question is find what type of control logic used and correlate its performance and with the type of control unit in module 3 in COIS syllabus. And to execute an instruction, the control unit of CPU must generate a required control signal in the proper sequence. And there are two approaches used for generating the control signals in proper sequences: and hardware control unit and microprogrammed control unit. And hardware control unit, the control unit hardware can be viewed as a state of machine that changes from one state to another state in every clock cycle, depending upon the contents of the instruction registers and the condition codes and the external inputs. And the inputs of the state machine are control signals, and the sequence of operation carried system by this machine is determined by the wiring of an logic elements, hence mentioned as an hardware. And fixed logic circuits that corresponds directly to a boolean expressions are used to generate and control signals. And hardware control is faster than the microprogrammed control. A controller that uses these approaches can operate at high speed. And RISC architecture is based on a hardware microcontroller. And this is the block diagram of hardware control unit of a computer. And next one is microprogrammed control unit. And the control signals associated with the operations are stored in a special memory units inaccessible by a computer. And a control words and control signals are generated by a program or similar to a machine language program. And microprogram control unit is lower in the speed because of the time it takes to fetch the micro instructions from a control memory. And these are the some important terms, and these are the block diagram of this microprogrammed control unit. And the eighth question is explain the memory management system in the processing element selected, and list its addressing capabilities and memory mapping technique you followed. Find the advantage of memory design and management technique. So the concepts given in the module 4 in COA syllabus. And the architecture of microcontroller may require the variables and constants be stored in different types of memory, and the data that will not be changed and will not be stored in one type of memory, will while the data must be written to representative in a program should be stored in another type of memory. And third type of memory can be used to store and variable data that must be retained even when the power is removed from the system. And SRAM is a type of memory where the data must be read and written in repeatedly. And this is the type of data will change with the different codes being uploaded to the AV or microcontroller unit. By default, this is the most common used type of memory, and flash memory is a memory that normals and does not change, and this is a program memory. It stores a part of microcontroller program. This is fixed and will always stay permanent, and this is a similar to an BIOS general purpose computer. And this is the block diagram, and this is an IO memory, and this is the block diagram of that, and these are the 5 addressing modes for a data memory. And the ninth question is elaborate the pipeline and the parallel processing capabilities of a unit and the hardware management technique. And pipeline is a process of accumulating instructions from processor through a pipeline. It allows the storming and executing instructions in an orderly process. It is also known as pipeline processing, and pipeline is a technique where multiple instructions are overloaded during execution, and pipeline is divided into stages, and these stages are connected with another from pipe-like structures, and the instructions enter from one end and exit from another, and pipeline increases the overall instruction throughput. In pipeline system, each segment consists of input register followed by a combinational circuit, and the register used to hold data and the combinational performance operations in it. And the output of combinational circuit is applied to an input register of next segment. And these are the types of pipelines, and there are two types: arithmetic pipeline and instruction pipeline. And arithmetic pipelines are usually found in the most of the computers, and the computers are used for floating operations and multiplications and the fixed pointing numbers. For example, the input to the floating point added is pipeline, and this is the example for that. An instruction pipeline, in this, a stream of instructions can be executed by overlapping switch and the decode and execute phases of instructions cycle, and this type of technique is used to increase throughout the computer system. An instruction pipeline reads the instruction from the memory with the previous instructions are being executed in the other segment of a pipeline, and this can be executed where multiply and instructions simultaneously, and the pipeline will be more efficient in the instruction cycle and divided into segments of equal durations. And find whether the processor level parallelism is available in eliminated selected, installate the cache coherence and the proctal used for handling memory hits or MIAS, and the processor level management is available in DLP-PC7541, and the and this is the cache coherence of that, and this is the interprocessing communications. And thank you. This is my DA-1 for giving this opportunity. Thank you for everyone.